In class, we talked about the graphs of sine and cosine and how to graph them. This podcast is going to be a review of the techniques that we talked about, and I've got some samples for you to try at the very end. So let's get started. Here we have the graph of y is equal to sine of x. And as we talked about when we were working with our unit circle, the domain of sine is all real numbers. You can see there are no gaps in this curve. So the domain is all reals. And your range, your maximum here is 1, and the minimum is -1. So that means we have a range of -1 less than or equal to y less than or equal to 1. So y is always going to be between -1 and 1. You can see here we have 3 intercepts. What I've got highlighted here is just one cycle of sine. The 3 intercepts, the first one here, this is the initial point. We've got 0, 0. And the second intercept you're going to have at pi 0. And your last one is at 2 pi 0. So this means that one cycle is completed over 2 pi, and that means that the period is 2 pi. Our sine function has a maximum at pi over 2, 1, and our minimum is at 3 pi halves, -1. And you can see that the pattern just repeats over and over and over again. Okay, next let's take a look at some of the basic features of our cosine curve. So this is a graph of y equals cosine x, and just like sine, you can see that our graph doesn't have any gaps, so that means our domain is all reals. Just like with sine, our maximum value is 1 and our minimum value is -1. So that means that our range, again, y falls between -1 and 1. Here we have highlighted again one cycle of cosine. You can see we start off, instead of at 0, 0, at 0, 1. That's your maximum. Then we have a minimum at pi -1. And we have another maximum. Let's go back and make a note here. This is the minimum. You have your maximum at 2 pi 1. So that means that just like with sine, cosine has a period of 2 pi. Our intercepts for cosine, at pi halves we cross, so pi over 2, 0, and at 3 pi halves. Okay, so that was just a quick review of the cosine curve. Now let's take a look at the general forms of their equations. out in front, we have A, and A stands for the amplitude, and keep in mind it's the magnitude of A. You can't have negative amplitudes. And if you have a graph and you're trying to find A, then what you can do is look at halfway between, so half the distance between the maximum and the minimum. Okay, now let's take a look at what is B. Well, we use B to define our period. So the period is equal to 2 pi divided by B. Now the whole quantity here in parentheses lets us define our horizontal shift, and the way that we do that is by looking at the left and right endpoints. So in order to get the left endpoint of one cycle, you set bx minus c equal to 0, and then you solve for x. For the right endpoint, we're going to set bx minus c equal to 2 pi, and then solve for x again. And this is going to let us define one cycle, and then we can just repeat the pattern to get the rest of the graph. Now this last part is our vertical shift. So D defines your vertical shift. Okay, let's try an example. So we're going to graph 2 sine of x minus pi over 2. Well, first of all, we have an amplitude of 2. B is equal to 1, so that means our period is just going to be 2 pi. And we have C equal to pi halves. So that means we've got a horizontal shift, and we can get our left endpoint by setting x minus pi halves equal to 0. So that means our left endpoint is x equals pi halves. Our right endpoint is going to be x minus pi halves equals 2 pi. So solving for x, we get x is 2 pi plus pi halves, which is equal to 5 pi halves. Okay, so let's start graphing. What I have for you already drawn here is a sketch of, this is y equals sine x. And we're going to use this in order to help us graph our points. So our intercepts we've got our left endpoint of pi halves. So let's go ahead and put a dot there. So that is pi halves 0. Our right endpoint over here is going to be 5 pi halves 0. Let's go ahead and put that on our graph. And then to get the third intercept for sine, you just look at halfway in between pi halves and 5 pi halves, which puts us here at 3 pi halves. So now we've got our 3 intercepts, and halfway in between our left intercept and the center one, so that's at pi, that's where we're going to have a maximum. Now since our amplitude is 2, our maximum is no longer 1, but 2, because we multiply the amplitude in order to get the maximum. So your max is now at pi 2. Okay, to get our minimum, we're going to go halfway between the middle intercept and the right endpoint, and that's going to put us at 2 pi. Looks like I'm going to run into my writing a little bit. So down here at -2 is going to be our minimum. So 2 pi -2 is our min. Okay, let's go ahead and draw in our curve. So this is now one cycle, a little shaky, sorry about that, one cycle of sine. Now to complete it, from pi halves, we're going to go down again to -2. At negative pi halves, we're going to be crossing again. And we'll have another maximum at negative pi. And here on this end, we're just going to continue up to our maximum value again. And there we have a complete drawing of y equals 2 sine pi minus x over 2, or sorry, sine of x minus pi over 2. And you can see that your period is still 2 pi. Okay, let's do another example. Here we have the graph of -2 sine of 2x plus pi. So we've got an amplitude change, we're going to have a period change, and we're going to have a horizontal shift. Our amplitude, again, is going to be 2. B is equal to 2, which makes our period equal to 2 pi over 2, which is equal to pi. C is equal to minus pi. So let's get our endpoints. For our left, we're going to have 2x plus pi equals 0. And the reason it's plus pi is because remember when we looked at our general equation, this is bx minus c. So negative pi will result in that becoming positive. Okay, solve for x, and we get x is negative pi over 2. Now our right endpoint we're going to have 2x plus pi again. And for the right one, we set that equal to 2 pi. So now solving that for x, we're going to have 2x equals pi. So x is positive pi halves. Okay, let's go ahead and get our intercepts on there. For the left one, we're going to have negative pi halves, 0. For the right, we're going to have positive pi halves, 0. Halfway in between those two, we have the point 0, 0, so that's our third intercept. Okay, now let's look at our maximum and minimum values. Normally, sine between the left endpoint and the left endpoint and the center intercept, normally there we would have a maximum, but if you look up here, we've got a negative sign, so that means we're flipped over. So halfway between here, which is pi fourths, we have a minimum with coordinates minus pi fourths, negative 2. Okay, then let's go halfway between center and right. And there we're going to have a maximum and that's at positive pi fourths, 2. Let's go ahead and draw in this first cycle. Okay, now let's complete the cycle. So again, we go minimum, intercept, maximum. And you can see this graph is much narrower because our period is pi instead of 2 pi. And in between each set of marks that I have down here, so in between each pi half, that's where my min and max go. Okay, so let's just finish up this left-hand side. And there we have the graph of y equals minus 2 sine 2x plus pi. So we've shifted to the left by pi halves and we've narrowed our graph. Okay, I've got one more example. Okay, for our third example, we have the graph of y equals cosine of x over 2 plus 2. Since there's nothing in front of cosine, we know that our amplitude is going to be 1. B is equal to 1/2, so that makes our period 2 pi divided by 1/2, which equals 4 pi. So now we're going to be stretching out cosine horizontally. Since we don't have a C value, we're not going to have a horizontal shift, but we have a plus 2 here, which means we have a vertical shift up 2. So what that means is that our equilibrium line has been shifted from the x-axis up here to y equals 2. Okay, let's go ahead and get our intercepts. Our left endpoint is going to be still, x is going to be 0 because remember we said we didn't have a horizontal shift, and it's going to be 1/2 x is equal to 0. So x is 0. And remember cosine, see down here we had 0, 1 as our left endpoint. Well, that means that we're going to be up here for our max at 0, 3. So our left endpoint is 0, 3. Now your right endpoint you're going to have 1/2 x equals 2 pi. So that means our right endpoint is going to be at 4 pi. And again, if we look down here at the graph of cosine, at the end of one period, cosine should be at a maximum. So we're going to go over here to 4 pi, and we're going to put a point in at the maximum, which is 3. So our second endpoint is at 4 pi 3. So this point is 4 pi 3. Now if you look again at the graph of cosine, which is right here, halfway in between our left endpoint and our right endpoint, we have a minimum. So our halfway point, because our period is 4 pi, our halfway point is going to be at 2x, and our minimum is going to be 1 unit down from our equilibrium line. So that means that our other intercept our intercepts are going to be halfway between there. So we're going to have an intercept here at pi, 2, because remember we intercept that equilibrium line. And then your second one is going to be halfway between 2 pi and 4 pi, which is 3 pi. And again, we shifted up 2 units. Okay, now we've got our 5 points that we need. Let's go ahead and connect those. And continuing our pattern, to the left and the right, there we have the graph of y equals cosine x over 2 plus 2. Okay, I hope these examples have helped you. And now I've got 4 problems for you to try. Good luck with those. I know you can do it. Great job, everybody. And we will see you in class.